Thank you, Sarah, and thanks to our speakers so far. As Sarah said, I'm in the last talk in this session. My name is Tanya Maurer from MBARI, and I'm one of the data managers for GO-BGC and Tanya. And I also serve as co-chair for the BGC Argo data management team. So I'm here to give you sort of a brief overview of the data system, as well as how you can access the data. And of course, you can review the extended talk online for more details. So I wanted to start this off the bat with showing you the different data access points available to users. And really, these can be grouped into two main categories. The first being the products that we assemble and serve through the pre-existing international Argo data system. And then the additional file formats and derived products that we provide to users solely through the MBARI processing pathway with support from SIO. And both of these options provide archiving with DOI as a service to users, but there are some differences within the different products available within the two data systems. And that includes the differences in timeliness of the different products, but really the big difference being with the Argo data system, it really supports a standardized file structure across all data assembly centers internationally. So if you're interested in performing global analyses using all the data from all BGC Argo floats, that's going to really be your best source. And we will point you to the SPROF files, which I'll talk a little bit more about later on in this talk. But if your primary interest is in more towards the derived carbon parameters, as we introduced, these are not present in the Argo files. So you're going to want to turn to the MBARI served ASCII products there. So that's sort of the bottom line up front of how you can get the data. And then I wanted to kind of take a closer look at some details related to these two separate processing pathways. Ken mentioned early on in this workshop, all GO-BGC floats are Argo floats. I have an image there of the first deployments within GO-BGC, and that map was created using Ocean Ops, which is a great tool for users for exploring the Argo system and the BGC Argo floats available worldwide. And as you've heard, so by now, GO-BGC is really going to be a major contributor to the global BGC Argo array. This array is already expanding. As you see on the right here, the BGC Argo floats depicted in red, there's currently 402 operational worldwide. The US is already a major contributor, and there's lots of data that exists already from other international partners, so that's something to keep in mind. Oops. Okay, so a bit about the international Argo data system itself. There's 11 data assembly centers worldwide, and AOML in Miami is our official US stack. So we work really closely with them for getting our assembled Argo files out to you and onto the two main central GDACs or repositories for user access. The data comes in as two separate data streams. There's a real-time data stream where automated QC tests and flagging and adjustments get applied. And then for the highest quality data, there is the delayed mode data stream where careful review of the time series is performed by data managers in comparison to reference, and adjustments are derived. It's important to note that the core Argo data system, as has been mentioned, has been around for quite a long time, longer than the BGC, and so it was extended to the BGC into the pre-existing Argo system. And the data management is more complex for BGC. As Yui described, all BGC data requires adjustments prior to use, and we're still kind of in the early days of BGC Argo data management, but there's some great progress that's being made. The International Argo Data Management Team is a group that comes together to really forward the progress of the Argo data system, and with a primary goal of really finding efficient ways to increase the level of high quality adjusted data at the GDAC accessible to users across all parameters. So there's a lot of, this is really a community-wide effort. There's a lot of sharing of tools and resources that goes on, as well as recently the development of some system-wide parameter audits that have really helped to bolster the amount of delayed mode data available to users. I have an example here for the deoxy audit on the right that was developed by Josh Plant, and implementation and adoption of that audit has really significantly helped to increase the level of delayed mode data, as we see on the bottom right here, the green line surpassing that of the real-time data streams back in early 2020. And this is an image here of ADMT back in 2019. So now I just wanted to drill down into and give you an introduction of the GDAC file holdings and what's going to be most useful for you as BGC data users. And again, you can refer to the extended talk for more details, but we'll just kind of highlight some key points here. Again, as I mentioned, there's 2 central repositories for Argo data, 2 GDACs. The French GDAC and the US GDAC with links listed there. And these are mirrors of each other. So their file structure and their holdings will be identical. So on the right here is an image of what's inside inside the GDAC Argo reference, or excuse me, repository. And there's a number of index files, as you see here at the top, that can assist you with kind of categorizing floats in various ways. And what's going to be of most interest to you as a BGC Argo data user is this synthetic profile index. And those of you attending the data tutorial will get kind of more exposure to that later on in the workshop. But this really serves as kind of a directory listing for synthetic profiles that are available to you. And you can kind of subset floats. This is an easily parsable list, and you can kind of subset floats based on what you're looking for, location, parameter, data mode, etc. And then the DAC directory further down here is where you'll actually find the SPROF files and the data that you're interested in. So what are these SPROF files, and why should you be using them? They are a one-stop shop for core and BGC data from a float. All cycles are combined into one file, so a single file for the entire lifetime of the float. Core and BGC parameters are aligned on a single pressure axis. So the goal was really, with the development of these files, which was only fairly recently, a couple of years back when they were first implemented. The goal is to co-locate as many BGC observations as possible while preserving the character of the sampling pattern for any particular float. So there's really high utility here for the users. They're really easy to use, and they're really designed to facilitate widespread use of BGC data. So we encourage you to use these SPROF files, and you won't regret it. So a bit more about just the details of what to look for to get the highest quality data within the SPROF files. You're going to always, for BGC especially, you're going to always want to look for the adjusted parameter fields, as Yui introduced in his talk. You'll want to look for, of course, look at the quality flags, and for the Argo system, QC flag of 1. And then parameter data mode will direct you towards the adjusted fields either being A or D, but you'll want to look for demoded data to get, again, the highest quality with the lowest uncertainty. And that's data that's been, reviewed over time in comparison to reference to derive those adjustments that get applied to the data using various methods, such as the SAGE tools that we've developed at Mbari, highlighted on the right here. And we have a paper in review, as you mentioned, thoroughly describing these tools. So again, use the SPROF files. They're easily manipulated and ingested in using various software tools, as again you'll learn more about with the data tutorial. This plot here is a plot of all of the SPROF files across the whole Argo system ingested to Ocean Data View. And I'm plotting here oxygen percent saturation using the deoxy adjusted data, less than 50 meters, QC1 across all DACs. And I included this really just to highlight that BGC Argo data management, we're still in the early days, as I mentioned, and there's still some work to be done. There's some floats here that sort of pop out above 150% saturation as outliers, and likely need further review by data managers. So users would be wise to, trust the system, but look carefully at your data that you're interested in, and additional QC may be required. So that's the summary of the Argo data system, and I just have a couple more points here. I wanted to bring it back to our more internal GO-BGC program specific data management. This is a flow diagram showing a flow of data from float to user, and kind of the main point here is it's really a huge collaboration between different institutions. We work really closely together with, and aside from the products that we serve, there's a lot of additional tools and resources out there for data users. So I encourage you to review the GO-BGC website and look for some of those additional resources like float tracking tools and tables, as well as information on shipboard data. And Lynn talked a bit about shipboard data. It's really not essential to float operation, but a key part in the whole data management process and our quality assurance. It's used mainly for validation, not direct calibration of the quality control methods. And we really aim for having at least 50% of floats that have ship forecasts taken alongside deployment. So these continued float to bottle matchups, such as shown here for oxygen nitrate pH within the SOCOM array, and the associated statistics really, help support routine assessment of fleet-wide accuracy and help us to track this, how we're doing over time as we move through the program. You mentioned derived products served at MBARI or through MBARI process files. So again, these are available in the FloatBiz ASCII files. And these derived carbon parameters, including particulate organic carbon, total alkalinity, DIC, PCO2, these are computed in-house really to provide a consistency across the user base as a product to you. He mentioned the high quality pH measurements are needed for some of these parameters. And there's details in the headers of our ASCII files that kind of run through all of the equations and coefficients that we use to getting those to you. And in the future, we may move towards providing users with the tools and routines themselves to compute these for floats that are outside of our management system. Again, these parameters are currently only available for MBARI process BGC Argo floats, and this does include all GO-BGC floats and floats within the SOCOM array. Okay, so this is my last slide. I think I'm out of time anyway, Sarah. I can leave this up, but yeah, really the management system's complex. If you have a question, ask. There's some key points there listed about the Argo data system, what to look for. Lots of resources available, and really just always look at your data. Thank you.